and we're going to do a polynomial fit. And yes, we want to see what the equation is. We're going to do format the trend line label so that we can see in more detail what it is. So scientific, and then we're going to have put in for decimal points, make it bigger so we can see it, and then copy it. And this is now our equation. Put it down here. And so if you will, this is y is equal to ax squared plus, well, actually it's y real is equal to a times y tracker squared plus b times y tracker plus c. So that's what we have. Okay, I don't know why that got changed. And now this is going to be, well, actually, you don't have to do anything more with it. We have this function here. Let's put that over here. Copy that over and put it into our ball data. There we go. Well, maybe we ought to get rid of these two things, and let's just do a copy of the whole entire sheet. And then put that into sheet 4. Call this ball data 2. The idea is that you want to keep it all clean, clean it up. Okay, so now we're going to have a now, if you will, we're not really interested in the delta YC versus Y. So let's just get rid of this. Instead we're going to put in our correction for stuff right here. Okay, so this is now going to be YC 2, and what we want to do now is, let's see, let's put it, or we want to expand the sheet a little bit more, if you will. We want to capture these two things here and put that somewhere. Probably here looks like a good spot. And so this is going to be YC real, and here we're going to do so this is going to be 2.4909 e to the minus 4. This is going to be 9.2813 e to the minus 1, and this is going to be minus 3.6501. Okay, so this is our A, B, and C. We could copy this up to here, and we could insert a couple and then pull this over. This will be A, B, C. And then over here we're going to have, this is going to be equal to A times our previously corrected value squared plus B times that plus C. Okay, let's not forget to put in our dollar signs where appropriate. So there. Okay, so you forgot to include in here, forgot to include the B. And let's put in parentheses just to make sure things are reasonable. So we have that. Here we go. Okay, so I think we're all set. Okay, so let's copy that one down to here. We'll check it. It looks good. Okay, so now we're going to do a copy and paste. There we go. Now we want to just, the simple thing to do would be just to switch, not look at row G, but look at row H. Okay, we got that guy. And now we're just going to do a copy and paste. Boom. Slide down to here. And all of our plots ought to come up just fine. Okay. Okay, so let's see. Okay, so our plots should come up fine. But it is no longer, we're no longer looking at, well, we're still looking at the original data. So if we select the data and we're looking at VY, so it's looking at column L, which should be now corrected. Okay, so that should be okay. Oh, let me see. It's looking at ball data, and we want to look at ball data too. Okay, so let's put in ball data too. Okay, let's see. Oh, yeah, it's looking at the wrong thing completely. Okay. It's more than ball data too. We moved over the series to N. Okay, so that's what we want to do. So this wants to be M and N. There we go. Boom. Okay. And now what we have is, we have a linear fit. You can see that the polynomial sits right on top of the linear function, and we're pretty much set. We would do the same thing to find the best value using the same methodology of looking at different values of G and finding out what the chi-squared was for those different values. And then you find the minimum and then find the error from the parabolic fit of chi-squared and our changing of value of G. Okay, but one of the things to notice right away, though, is that the linear fit and the parabolic fit that Excel would do sits right on top of each other. Okay, that's about all I have on this one. Basically, we don't need to complete the trying to find the best value of g, because we've already done that once before. You would want to finish this out and find out what is the best value g you can get. Okay, thank you very much.